Alright, welcome to 7-7, distance from a point to a line. I'm starting off with a warning here because the book starts with how we get the formula and then moves into examples, and it's really confusing how we get the formula. So I'm going to start with actually Algebra 2 methods of solving this problem, move to the formula that they gave us, and then show you how to do it. After that, you'll be able to take a short break, and then you'll be able to do problems to see how well you understood all of this. Before we get started, let me just remind you what it means to find the distance between a point and a line. If I have a point here in blue and that line, that distance is the segment that is perpendicular to the line. And so I'd have the little perpendicular box here, and we're looking for that distance right there. So I'll just call that D for distance. If you turn to page 471, you'll see this as example 1. You could already see then how quick and easy the formula is compared to the method that I'm going to do using these 5 steps here. What I'm going to do is pause as I do the problems, so they'll just suddenly appear all the work. But let me talk you through what I'm doing on each step. I first find the slope of the line, and that's the given line right here. And so I won't pause this one, but that's y equals, I'm going to subtract the 8x over. The 20 is already over there. So I'm going to divide by 5. That doesn't reduce, but 20 divided by 5 is 4. So the slope of that line would be negative 8 over 5. Then the opposite reciprocal will be the slope of that red line there. So that new slope that I'm looking for is going to be positive, and it's going to be 5 over 8. And so that's the first 2 steps done right there, and that was relatively easy, but this is where things get a little bit harder. Step 3 is use that in the point to find a line perpendicular to the given line that passes through the given point. That's the line, the red line right there. And in order to do that, I'm going to use y minus y1 is equal to m times x minus x1. That's the point slope form that you learned about years ago, and hopefully remember or recall it. And again, these are old methods, so if you're sitting there right now and you're like, I don't remember any of this, that's not too bad. You hope to have some memory, but focus right now on following along, because we're going to learn a new method, and when you come to test, you won't have to do this method that I'm showing you right now, unless you want to check your work. But it'll be good for you to look at it and see and recall it. I do suggest you take notes on this, write what you see up there. If you want to ask the teacher to pause so you get everything, you have that. You could also access this online as well, and so that you can write everything down and watch the video again. So I'm going to pause, do the problem, and then we'll go from there. You won't see the pause. I'll immediately come back, which is just wild. Okay, just like magic, now you'll see that in blue I have solved for y, and y would be the equation of the red line there, if that was a full line. Now what we have to do is find where that point, or where the point where they cross. And so we have found the equation of the line perpendicular and passing through the point 4, 5. Now we want to find out where both of those points cross. So again, I'm going to pause and do the math for you. Okay, so this is a little long and tedious here. All right, so that was a little bit tedious right there, but in red you can see what I've done. I used the substitution method to put the new equation in. I then solved for x, which was a little bit crazy to do, but I eventually got x equals 60 over 89. And then from there, I plugged it into the y equation I had for this line, and cranked that out to get 260 over 81. I then looked at both of the two equations right here, and we had to then use the distance formula, which is right here. X2 minus x1 squared plus y2 minus y1 squared would be approximately these values here, which then you take the square root and you get the answer. You could look real quick on page 471 and you'll see that that's the answer they got in the book. And so now let's do it the easy way. We'll go ahead and use the formula to do the same problem. You could follow along in the book too, but go slow on that. Let's go step by step to make sure that we understand what's happening here. And so starting over, you have the point 4, 5, and you're given the equation of a line, 8x plus 5y equals 20. The first thing in order to use this formula, and the formula that we're using, I'm just going to write over here, is d equals capital A x1 plus b y1 plus c all over plus or minus the square root of a squared plus b squared. And I'm going to explain it as we go, and then when I show you the formula of how we got it, we'll go back over this again. But the first thing that you got to do is you got to put this in standard form. Standard form just has the 20 on the other side. And so I go 8x plus 5y minus 20 equals 0. That's the first step. And the reason why that's important is so that we can key off of this sign right there. Is that positive or negative? And so we take the formula, d equals, now a, b, and c, capital A, B, and C, are these three numbers, 8, 5, and 20. So I could write 8 times something, we'll go back into that, plus b, which is 5, times something, plus c. Now it's plus c, but when you're in standard form, there's really a, I'll write it right here, ax plus by plus c equals 0. So when you have a negative, the c is negative. So I'm gonna write it like this. The book has minus 20 there, but it's really plus negative 20. And typically we just do that in our heads as we go. Okay, then we're going to divide by, and I'll leave this as a plus or minus right now. We'll figure out which one it is at the end. But we're going to do a squared, which is 8 squared, plus b squared, which is 5 squared. Then the other two values that we're missing here, all that is your x and y. So that's just plugging in your x and y here. So we could put the 4 here and the 5 here. And so far that's it. That's our formula. The big question is it plus or is it minus? And let's think about that right now. What you do is if c is negative, you use the positive. So our c is negative, so we'd use the positive. So we could write this in your notes here. Negative, or c is negative, we use that one, and then c is positive, we use the negative one. So another way to look at it is it's the opposite of what you see there. And so you can go ahead and do the math here. I'm gonna pause it, do it, and then you'll see it. Okay, I'll be honest with you, the reason why I keep pausing it is because I keep messing it up and having to restart the video. And so I pause it, make sure I do it right, and then I go back over it. But I did this one right, and so we could continue on. Again, the formula is as easy as it looks. We did it in just a few steps. You multiply everything across, you divide by the square root, you figure out if it's positive or negative by looking at the opposite of c. And then you have the same answer that we got. Instead of doing all of this work, our new formula allows us to just do it right there. So why does this work? That's tricky. It's really tricky to show you without looking at the book there. So I really need you to be on page 400, and I just want to talk you through it. If you look at page 470, you'll see where they have the blue and the red dotted line. And look and find D and P, and you'll see that you have a distance and a point there. And what they're able to do is to show you that if you're looking for point P, now I will need to draw a little bit. You have a line right here, and then you have the normal of that line, and so we're looking at the perpendicular distance from the origin, and then they show the theta or the phi right there, and then you have this distance and then the point P that we're looking for, and then the red dashed line is the parallel line to the blue line there. So make sure that you see that, but the P that we want is right here. I think they put x1, y1 there for you. But what they do is they go over, and I won't go into detail on this, but they explain how they're able to get the equation D equal to this right here. And just like in the last section where you learned polar form, that's where you see this. I'm actually doing this video before I cover this 7-6 in class, and so but by now you should know what the polar form of an equation looks like, and it's right here. And then what they do is they say, well, x1, y1 is on that line, so I can change from a generic x to the actual x1 that I am looking at right here, and likewise with the y. So these aren't variables anymore. X1 and y1 are the actual terms that we have. And then once we get there, what you have to do is you have to go back to the previous section, and you'll see that changing back and forth from the polar form of the equations, you'll get to figure out what cosine phi and sine phi is, and that's on page 464 to 465 is where we learn about where all that comes from. And likewise, what happens there is you're substituting sine phi and cosine phi and p, and if you look at it near the bottom of page 465, go ahead and turn to that right there. You'll see this right here. You'll see ax over plus or minus the square root of a squared plus b squared plus by over plus or minus the square root of a squared plus b squared plus c over plus or minus a squared plus b squared. And if you look at that, if you're adding all that together, you'll see that equals the distance formula that we just learned. And so they quickly go through that. They also put absolute value bars there because distance is always positive. If it was negative, it's really more of where the line is located compared to the point. And they get into that in the example, and you could read that through. But that's where it all comes from. And if that went over your head, or if I didn't explain it enough, or the book doesn't explain it enough, don't worry about it. You can try to figure it out. If it comes to you naturally and you're like, I totally understand this, maybe you should think about becoming a math major because you're gifted. But for the rest of us in math, even myself included, when I was taking this class, it's the formula that matters. Can you find the distance between the line and a point. And if you are given 2 lines, then you got to figure out 1 point on 1 line to do that. Anyway, let's go ahead, and right now would be a great time to take a break in class. And so if you guys could pause the video here, I would imagine that you can use a good 3 to 4 minute break, and then come back ready to do some more problems with me. All right, I trust that you had a good break and are ready to go. I do want to point out, before I get into problems, I do want to point out a couple things that the book has. If you look on page 471, you'll see example 2. And what they don't talk about in example 2 is that those lines are parallel. So they're parallel. If you look at the slopes, if you calculate the slopes, they're going to be the same slope. And then they chose x equals 0 on one line, solved for y equals 4, just to get a point. And so if you're given 2 lines, you double check real quick that they have the same slope. If they're the same slope, you just have to find any point on one of the lines and then use the second line in the formula. The next thing that they have is on page 472. On page 472, there's the relative position of the origin. You could read that through. I'm not going to cover that. That's not going to be on a test, but it's just you can look at the sign, and that also tells you where the point and the lines are, whether it's positive or negative. It's just another thing to look at. What I'm interested in is for you to be able to do problems 11 through 24. By the time we finish, my hope is that you are able to do these easily and effectively. And I'm going to pause here because my little puppy is crying, and I want to find out if it pooped so I could clean it up. And so I'm going to pause, and hopefully you got a little good chuckle out of that, and I'll be right back. All right, I lucked out. No poop on the floor. And let's continue. So I'm going to leave the odd questions for you to check in the back of the book. I'm going to start with number 12. So right now, you might want to ask the teacher to pause pause the video so you can write out number 12 and try to do it. You might be able to do it all by yourself, and then after enough time, the teacher could unpause, and you could see the solution as I go. Or if you need me to pause and need some extra help from somebody at your table, please raise your hand and do that as well. So we're given a point 5, 3, 5. We're given a line 5x minus 3y plus 10 equals 0. And it's already in standard form for us. So I like to write the equation out. We have ax plus by plus c all over plus or minus the square root of a squared plus b squared. And remember, that's x1, y1, and the distance equals that. So everything's ready to go. You just plug it in. A will be 5, x1 is 3, b is negative 3, y1 is 5, c is positive 10. So that means, this is where we could change our sign already, that means that this has to be negative. So we got negative a squared, which is 5 squared, plus, I forgot the squared on my formula, 3 squared, negative 3 squared. You don't have to write that because when you square you don't have to write the negative, because when you square it becomes positive. But we come here, and just for fun, try to do all these without a calculator as far as you can. It's good exercise to do the simple math in your head. So 5 times 3 is 15, minus 15, that's nice, plus 10, all over negative, and we get Did I write it down right? Looks like it. We got 25 plus 9. So I have 10 over the square root of negative 34. So if I multiply top and bottom by the square root of 34, I'll get 10 root 34 over 34, and then I keep on, what I'm doing here is I'm touching the button every now and then, and it's making my drawings funny. Oop, press undo too many times. Let's see if I can do it better. So we got 10 over root 34 divided by negative 34. Now, the negative really doesn't matter for us. That's more of where the point is. If you get a negative, and it is possible to make a mistake and then actually get it right at the same time if we put the wrong value in. If positive or negative, just remember distance is always positive. So 2 goes into 5, so 5 root 34 divided by 2 goes into 34, 17. I'll still put the negative there, but the distance is going to be positive because distance is always positive, and we're good to go right there. Okay, so again, you might want to pause a little bit and wait until you do the problem to watch the rest of 14. See if you can do 14 all by yourself before I do it. Alright, so I wrote the problem out, and just to keep memorizing it, write the formula out too. Oh, I did it again. There we go. Okay, so hopefully you can pause here if you want to, or hopefully you got the same answer. Alright, so distance equals I forgot to put this in standard form. So on here, I like positive values, and so I'm going to rewrite this as 2/3 x plus y minus 4 equals 0. And so I would have 2/3 times negative 2 plus 1 times negative 3 minus 4. And since that's negative, this would be positive. Root a squared would be 2/3 squared plus b, which is 1 squared. This might be a little trickier to do without a calculator, but try to do all your fractions and everything without a calculator. I would get negative 4/3 minus 3 minus 4 all over, that's going to be the square root. Let's see, let me do it here. That would be 4/9 plus 1. 1 is the same thing as 9 over 9, so that will be 13/9 underneath the square root. Or you could write the square root of 13 over 3. Square root of 9 is 3. At this point, I don't like fractions, so I multiply top and bottom by 3. You got to be careful because you got to distribute it into the whole thing. That means that 3 times negative 4/3, the 3's cancel out, but the 3 times negative 3 would be minus 9, and then 3 times negative 4 is minus 12, and I would be stopped right there. Alright, so now we have see, negative 4 minus 9 minus 12, that would be negative 25 over the square root of 13. And remember, we're not worried about the positive or negative here. Everything just needs to be positive for distance. So here they rationalize the denominator. I have no idea if you guys can hear my puppy, but she is going nuts. So hopefully you can't hear it. If you can, I'm sorry. So 25 root 13 over 13. Okay, so let's look at number 16 real quick. This one, try to do it completely before you see the answer here, and then you could watch me do it, and then hopefully we'll get the exact same answer. So pause right there and while you do the problem. Alright, so let's get started on this. Again, just I'm serious about this. Write out the formula for every one of these. It just makes memorizing it that much easier. And also, like the whole plus or minus, I know I just barely covered it, but remember that it has to do where the point is compared to the origin, if the whole thing's positive or negative, and this number here has to do with the number that we get from C as well. So I'll do the problem, but I won't worry about that in the end because we're just trying to find the distance. So on here we got to first convert this to standard form. We got 4/3 x. I'm going to bring that to the left side. Minus 6 equals 0. So using -6 here, I'm going to use a positive on the bottom. Then whatever's on the top, if it's plus or minus, you'd be able to figure out where it is compared to the origin. You could look at example 2 to better understand that if you'd like to. But let's keep going. So 4/3 times -1 plus 1 times 2. So 4/3 and 1s come from A and B, and -1 and 2 is from the point. Minus 6 all over 4/3 squared plus 1 squared, and you got to take the square root of that. And so go ahead and pause there and see if you guys can figure it out. Alright, so hopefully you're back. And if you're not pausing, it's just I just sound like a goofball, I'm sure, and that's okay if you laugh. Especially Tommy. I bet he's laughing. Okay. Oh, I meant to do that problem there. Let me erase that. So 4/3 squared. Oops, went too far. So 2, 6. Okay. So 4/3 squared would be 16 over 9 plus 1. I'm going to go ahead and write 9 over 9. I got to remember that I'm still taking the square root. Oh, we didn't evaluate for this since that was C was negative. It is positive, so that's fine. On top, we would have -4/3 minus 4. On the bottom, we have square root of 25. That's 25 over 9. So we have 5/3. And again, if I multiply top and bottom by 3, I could clear my fractions. I get -4 minus 12 all over 5. So that would be -16 over 5. Now that negative has to do with what we're looking for, so we drop it because distance is always positive. Alright, so that's one type of problem. 17 is something that you want to look at. What is the distance from the origin to the graph? You could look at the answer in the back of your book. Go ahead and play around with that, and then and see what you come up with. I'm not going to say anything more on that, but it's not too hard of a problem. But you gotta be careful what you do with that. Not too careful, but go ahead and figure that out. Number 18. So now what we have is we have two parallel lines, and it looks like it's a harder problem, but it's not. You know that these two are parallel because they have the exact same slope, and if they have the exact same slope, they're parallel. So they told us, and they have the exact same slope. So what we really have to do is we have to choose one of these lines, and then you have to pick a point on that line to make everything easier for you. The line that I would choose would probably be the first one, only because 3 goes into 6. And so if I chose y equals 0, you can see that 6x minus 8 times 0 is 0 equals 3. So I got 6x equals 3, x equals 1/2. It didn't give me a whole number, but it gave me a reduced fraction. That's why I chose it. You could have chosen any number. You can choose something that might make y easier. It doesn't matter, but I have 0 and 1/2, and now I'm back to the neg 1/2 and 0. Now I'm back to the same type of problem that you had in 11 through 16. Here's a point, here's a line, and then let's go ahead and find the distance from that. And so distance will be equal to, let's go standard form, 6x minus 8y plus 5 equals 0. So c is plus 5, so I'm going to go, I have a x1 plus b y1 plus c over, since it's positive, I would have that negative, and that would be a squared plus b squared. And so now we have 6 times 1/2 plus b, which is negative 8, but negative 8 is going to be multiplied by 0, so that will cancel out, plus 5 all over the negative square root of 1/2 squared plus 0 squared. So I'll just write 0. Well, write the squared anyway. And so 6 times 1/2 is 3, 8 times 0 is 0, plus 5 minus 1/2 squared. Square root of 1/2 squared is just 1/2. So here I just flip and multiply. So multiply the top by 2. And let's see, 3 plus 5 is 8. And 8 times 2 is 16. But looking at the answer in the book, looks like I did something wrong. So I'm going to use this as a learning tool instead of redoing the whole video, which there's no way I'm going to do. Let's see if you could find where I made a mistake, if I made a mistake. Right now I have 8 divided by negative 1/2, so my answer is 16, which looks to be wrong. So let's see what I did, see if you can figure it out. I'll pause it, find my mistake, but let's see if you can find it quickly. Okay, did you find my mistake? Did you see what I did? If you look right here, when I chose my b on the bottom, I chose 0 when it's actually 8. So my mistake was right here. This should have been negative 8 squared. So if I did that, I'm going to go ahead and erase this part. So on top I would have, I'll just erase that. So I would have 8, and then I had 1/4 plus 64, and all that would be under a square root. And let's see, how would you want to do it from there? I have a common denominator of 4, so multiply top and bottom by 4 so that we can have it over 4. So that's equals to 8, and that will be 1 plus, now 64 doubled is 128, and if I double it again, I would be at 256. So that would be 256 all over 4. Take a square root of that. But hold on here. Okay, so now I'm totally embarrassed, and I wish I could just rewind and go back and start this over. I did that same thing twice. I not only did the a, I moved the point there, but I also did it for that a squared, or for the b term. I didn't just do it for the b term. I did it for both terms. So I'm going to start from here and go back. But there is no way I'm going to go and re-record the first half hour of this video. So sorry about that. Hopefully this will serve as a good lesson for all of us to double check. But a is 6, so that's 6 squared. And then the b is 8, negative 8. That's negative 8 squared. You don't have to write the negative 8 because you square it, it'll become positive. And then on the top we got 3 plus 5. On the bottom we get the negative square root of 36 plus 64. 36 plus 64 is 100. So you have the square root of 100, which is 10. And then you have 8 over 10. Now it would be negative, so all that does is tell you the placement. So I'm going to just convert to positive there, reduce that to 4/5, which is the right answer. Much easier question if you put the right numbers in there. So let's see if I could do number 20 and redeem myself and not make that mistake again. So number 20 is y equals 2x plus 1. 2x minus y equals 2. And first thing that you'd want to do here is choose one point. Now they told you it's parallel. You could look at this. If you subtract 2 over, then you have a negative y equals negative 2. Multiply by a negative, you'll see that they're the same. So they have the same slope. But again, the first thing that we want to do is we want to solve for a point. I'm going to go ahead and use this one here. Pause if you want to try to do this before I do it. But now we got 2x, so if I say that x equals 0, do you see that y equals 1? So my point is 0, 1. My formula, d equals ax plus by, x1, y1, plus c all over plus or minus the square root a squared plus b squared, not x1 and y1. Don't forget that. Okay, so I need to put the other equation that I used in standard form, so that's 2x minus y minus 2 equals 0. So the distance is equal to a, which is 2, x1, which is 0, plus b, which is negative 1, minus c, which is, or plus c, which is negative 2. And then since c is negative, we'd make that positive. And a, which is 2, so 2 squared plus negative 1 squared. Alright, double check, I got the right a and b. Good. 2 times 0 is 0. I wrote b here. Ooh, man, I almost did it again. Got those confused. To be honest, I get nervous making this video. Let's see. So the b is the negative 1. The y is 1. Okay. So minus 1, minus 2, all over the square root of 4 plus 1. So here we have negative 3 over the square root of 5. And when we drop the negative, rationalize the denominator, and you'd be left with this as the distance. Alright, let's keep going. I got 2 more problems to do with you, and then it will be the end. You can go back and work out all the odd questions if there's time in class. So y equals 8/5 x plus, or excuse me, minus 1, and 8x plus 15 equals 5y. And if x equals 0, y equals -1 for that line. So we got 0, -1. That means I got to put this one in standard form. And our equation, d equals ax1 plus by1 plus c, all over the square plus or minus the square root of a squared plus b squared. Okay, so let's go ahead and find our distance. A equals 8, x1 is 0, plus b, don't get this wrong, equals -5, y1 equals -1, plus 15 for c. Still keep hitting that thing. Plus 15 all over the square root. Now I would go the negative the square root. 8 squared plus b squared, which is -5 squared. Okay, make sure I got the right a's and b's there. So we got 0 plus 5 plus 15 all over -64 plus 25. So we got 20 over root 89. I'm dropping the negative. So that's 20 root 89 over 89. And that would be the correct answer. Okay. Actually, I'm going to stop there. On my count, this is 42 minutes of instruction without stopping. So hopefully you didn't stop too much. And if you didn't finish this, not a big deal. Everybody can see it at home, but you might want to watch it again or not. But make sure that you go through and do the odd questions so that you could test yourself if you know how to do this. Because, correct me if I'm wrong, but no, I'm not. This is the last section, so we'll be having a test over this pretty soon. And again, the test isn't going to cover how to get the formula. It's going to cover whether you could use it. All right, thanks a lot. Have a great day.